Hello, everybody. Thank you for watching this. It is my great pleasure to introduce some of the people that you, our community, have awarded in the first round of deep funding. And I think we have a collection of great projects here. So it is my pride and my pleasure to present, first of all, Johan Sammy and Ken from Carbix to show and present to you what their project is all about.
Sure. All right, I'm just going to share the screen. Let me know if everyone can see that.
Yeah, clear.
All right, just want to give a background on Carbix, and then we'll jump into the metaverse and the SNet application that we're working on for carbon capture. At Carbix, our main focus is reducing industrial emissions from cement plants to steel plants. All of these are critical industries. We rely on them every day. We're even using them now as we zoom along. But the challenge is these emissions are occurring on a daily basis. So every day, every minute, pollution, whether it be CO2 or greenhouse gases, are emitted directly into the atmosphere, and the jet stream carries these emissions around the world. What Carbix is doing is that we're going to capture these point source emissions, also direct air capture emissions as well, and convert them into useful product and material. This is usually a very tough concept for a lot of people to visualize and to understand, especially a big power plant that is a point source emitter. So we kind of started working the idea for metaverse installation and using avatars to kind of direct the user and educate them about what carbon capture is and how it can be implemented on their site. Really came across from, just talking with dozens, perhaps even 100 or so people that are emitters that were interested in trying to convey what we're doing in a very simple way. So as you can see, a process flow chart like this gives you a kind of like a flat 1D, 2D, basic understanding. So to understand the Carbix process, you would see this image. And we inject CO2, water, mineral ore into the reactor. And after the reaction is done, we have a durable carbonate where CO2 is stored. How we do this is very similar to what occurs in nature. When CO2 is piped underground, it will also turn to stone or evaporate from seawater. But in our reactor, which is real portion, we cut this down to a few minutes and a few hours. We start by injecting UVC treated water along with mineral feedstock into the reactor, catalyze the reaction with CO2 partial pressure. We also use high and low speed mixing to increase surface area and CO2 uptake, and finally heating. So once the reaction is complete, slurry is ejected. This is now a carbonate, and that can be later used in different forms. And the applications vary from construction to non-construction uses. So why do we need, or why we went the route of SingularityNET was really to help convince, or the metaverse was really to help convince users so they could see in real time, even albeit digital, but with real equipment, what a carbon capture array looks like. So this is the X2 that we're developing, and these are some of the scenes from the upcoming app. So here, if you're out of the plant, you can now visually see everything that's happening. There's the flue gas stack. There's the infrastructure that we're building to move the flue gases around. What we like to do, and then we want to create, not only is this a desktop app version that we're going to put out, but also can view it on Quest. So to kind of walk the user through, we're going to label all the equipment where you can click on each component and you'll get a call out, and you may even get the vendor name. We want to encourage some of our vendors and newly signed off-takers and pilot operators or pilot facilities kind of encourage and advertise their products. So through the walkthrough, you'll get not only gets an understanding of how carbon capture works, but we also get an opportunity to advertise products, generate pay-per-view clicks, and then another revenue ideas that we're currently brewing. And I'll turn it over to Ken.
It's fantastic, absolutely fantastic. For my part, my background is in visual communications, but I'd had the opportunity in the past for years to work with scientists as well, the Geological Survey, Department of Fisheries, European Environmental Agency. And so when this opportunity came up to work with Johan on carbon capture, which is so vital to our biosphere health, I just was elated, just jumped on it. And Carbix's trajectory also matched what I was trying to achieve in terms of immersive environments for education, for STEM, for scientific exploration as well. And this industrial walkthrough that we've been able to create together is going to be the first example. So I will share my screen. And I've put together a very quick presentation. Can you see that okay?
Yep.
Groovy. Okay, so this is based on a pitch that I did for Laval. The Ruby Room was nominated as a finalist in Virtual Worlds at Laval, France 2022. So the purpose of the Ruby Room in this case, of course, is to explore questions of science and culture and technology. So for our project, we're going to be focusing on the educational aspect, but also accessibility features so that we can widen the scope. And what we hope to achieve is essentially American Sign Language to text, wherein we can then evaluate it for linguistic tags, like important command words, verbs, and so on, and then translate that back into avatar instruction. I'll skip ahead here. Now, we have three components to our submission. The prime one is going to be the ASL capture, and we're going to focus that onto the script that's involved in the instruction set for the Carbix carbon capture operation. So that'll help us narrow the focus of the scope of our project to something that we have a very good chance of succeeding with. The other part of it is adaptive learning, having some sense of when we can deepen the complexity of a subject matter or skip it and go on to something else to later return. And I think that'll be mostly statistical. In terms of the avatar communication, we have previous projects in my company for both conversational IBM Watson, speech to text and text to speech, and also multiple choice through Unity itself, which is then expressed or communicated to the student as text to speech. So we'll be integrating that with the linguistic tagging element of the ASL to text to complete this package. So we'll devote some time to the adaptive learning, medium time to the avatars that's already partially established, and then focus the main portion of our time on recognizing those particular phrases in ASL. And then we hope to add to SNET's offerings, as well as widen the scope of who can participate in this amazing technology that Carbix has created. And that's it for me.
Thank you, Ken, and thank you, Sammy. It's cool to see this. Very nice visuals also, by the way. And for a very good cause, of course, CO2 reduction. What I always learned is that in the building industry and with concrete especially, there's a lot of CO2, what's the opposite of reduction? Emission, yeah. So it's good that you can turn that around in the building industry and perfectly aligned with the vision and ethics of SingularityNET, I would say. To be honest, what put me over, what convinced me in your project when I was looking at it before voting. Actually, I didn't vote, but what convinced me is that while you have this project and you're making things for this project, I understand that these services that you are creating will be put on our platform, but will also be available for general use. Is that correct?
Correct. That's the plan.
So anybody could use those services that you are creating. And can you maybe list very quickly for me which of these services that we can expect to see on the platform as a result of this project?
Ken, you want to take that one?
Certainly. We want to build in, of course, the most critical part is being able to have an element, of the ASL capture. That'll be the trickiest part. When we're developing, we're going to have controlled circumstances in terms of lighting and tracking hands and the speed of communication. The main focus of this will be converting that sign language, those phrases, to text, then being able to analyze it for command and being able to analyze it for intent using typical linguistic tagging. In my previous work on iOS, I'd used that directly, and so we hope to bring this to ASL.NET. Now, accompanying that, of course, is going to be some basic ability to do adaptive learning using primarily statistics. And then the second part, which is popping out of my mind for the moment.
Text to speech, I wrote.
Yes. Yep. Speech to text. So the idea, exactly, we'll work with an open source library to begin with, so we don't need to replicate the very basic work of linguistic tagging. And then we'll focus on the function of being able to convert those ASL gestures to a text format that we can then pipe through linguistic tagging. And then that will come back out of SingularityNET with responses for the learning script that we'll be using.
Well, there's a lot to like over here, but yeah, you're our big winner, so that's not unexpected. But yeah, the fact that you're actually able, well, first of all, that you're making a metaverse, but for educational purposes, I think that's already very interesting. And then also education on CO2 reduction is a nice add-on. And then that you are actually enabling people that communicate using sign language to interact with these metaverses. Yeah, that's wonderful. And I can totally imagine that if we have a good service for that on our platform, that it will find much more widespread utilization beyond what you're building yourself. So yeah, really hoping for that. So I wish you a lot of success in that.
Thank you. Credit must go to Johan for suggesting the ASL component of it.
No, hey, you know what? No problem. The only, what inspired me was my, for that component was my niece or my nephew. We just found out he's 3 years old. He's actually deaf. So, it's kind of like a mystery as to why he wasn't responding when we talked, when I would talk to him when he was, like 2. Everybody thought he was, just a slow learner. Turns out he's actually completely deaf in one ear and partially deaf in another. So that, kind of inspired it in a bit. But also, I know that a lot of this is a huge component is education, and education is key to sales. And we want to have Carbix name when it comes to carbon capture in the metaverse. I want that to be the space Carbix owns, so to speak. So we can see a lot of revenue opportunity potential in terms of advertisers and original equipment manufacturers tagging their equipment and then referring back to their sites or so that they can also generate sales. So the education part of it is great, and Ken's super good at that. But we got to sell, and that's ultimately what is going to sustain any type of business. And so Metaverse is kind of like this new sales platform. I think it's still a little wonky, but we're gonna smooth it out, or at least that's our plan, so that we want to kind of make it seamless that someone could watch one of our, download the app, go through it, and then connect with us seamlessly, and then we can start either a new project or deliver, or there can be sales from it of individual components.
Wonderful. Metaverse as not only educational, but also sales environment. Of course, we're also, as SingularityNET, doing a lot of initiatives there ourselves. through Sophia DAO, and there's some other initiative cooking somewhere. So yeah, also from that perspective, I think those services and your organization will fit in perfectly in our ecosystem. And I think we can support each other very well in the coming months and years.
Yeah, thank you. And Ken and I are very excited about this, and we're happy to get started. We've already started, but happy to continue.
All right, let's go. Success. Anybody else? Any questions for Johan or Ken? Then I suggest we'll move. Oh, sorry, Subir.
Now, just a quick, curious question, maybe tangential. So, what sort of metaverse building blocks are you guys using to build this?
So these are the scenes that we're making are actually already exist. So that scene is actually from a pilot project that we're working on, that we've been developing for the last few months. So our plan is to create real scenes of real locations, albeit digital. We really like the future realism effect. We want to take a real location, and it could look like a dump, so to speak, and then we could,
which you will transform, right? So yeah.
Yes. Trust me, the site you're seeing does not look like that in real life. Although all the geometry is the same, it's a very old site. It's not as pretty, so to speak.
No, but you're sort of painting the future picture, right? So that's very interesting.
Right.
Yeah, it's super.
Yeah. Thank you.
Cool. Thank you for that question, Subir. Let's continue to Justin Diamond from Hetzerk, telling us something about simulation of physical systems and molecular dynamics simulation. It sounds awesome, Justin.
Yes, hopefully we can learn a couple of new things from my slides, if I can share them. All right, so yeah, shall we start?
Bring it on.
All right, so hello everyone. My name is Justin, and here I'd like to talk a little bit about a project to implement decentralized physics simulations. So a little bit about the idea myself is I've been in and around computational methods in biology, chemistry, and physics, including incorporating machine learning models in this respect. So over the years, my interests have waned between various principles in mathematics, computation, and physics, settling on a philosophy that is implemented with a project that I'd like to call Hetzerk. So Hetzerk is a computational research and engineering project. It exists on the borderline between advances in computational physics and machine learning and some new principles in structured mathematics, and by and large, we're building a computational model of subatomic particles, atoms, molecules, and larger complexes. So we're attempting to position ourselves as the infrastructure for applied and theoretical material science and discovery. So this is because we believe blockchain solutions, especially for decentralized computation and AI, will transcend the modern disconnected approach for research and development. So we are developing with help from SingularityNET, and of course their computational spin-off NewNet. And eventually we're going to integrate everything with Cardano as well. So I'd like to give a little more creative overview of what we're trying to solve and the direction that we're trying to tackle. And so the world is full of structures, right? And these structures are intricately involved. So some have little to do with our macroscopic selves, and others that without them we couldn't exist. So a brief overview of the current state of the standard model of physics is there are four forces, which are really just objects with very, very precise mathematical characteristics. So these objects, sometimes if abstractly called atoms, are the study in chemistry. So for instance, we have the periodic table to describe some very, very basic properties of these atoms, like sizes, charge, mass. So are these the only characteristics of these atoms? No. But however, some characteristics are increasingly hard to describe. and others may not even be computable in the sense of Turing machines, which is what our computers are. So the main job of a chemist is to explore the nature of these objects and perhaps understand structures that allow us to compose them in interesting and meaningful ways. So for instance, if we look at what scientists call hybridization, which is the study of mixing atomic orbitals, which are really just descriptors of electrons on an atom. So this theory is used to study how atoms and molecules bond to each other and interact. Then we have, for instance, crystal lattices, which is the study of condensed matter physics. If you add small defects to these pristine crystals, then it leads to interesting quantum behavior, which is useful in the semiconductor industry. And then, for instance, in biochemistry or biology, we have these 20 canonical amino acids that bring about really most of what we know about, our selves, our human biological selves. So the universe of these physical structures is quite unimaginably large. And so that's all well and nice. But what does this mean for us? Well, we can take the gecko, for instance. So the gecko, through evolution, has developed these biomechanical means to climb walls. They do so by maximizing a quantity called van der Waals interactions, which essentially models the electron fluctuations between different, usually between different atoms. And this ends up leading to attractive effects. So in biology, there are these cool overarching driving principles through evolution that allow us to extremize certain effects. So in the case of geckos, it means that we're able to maximize and increase the adhesive qualities of geckos' feet. So we go from these low-level physics principles to high-level use cases via some uncovered physical properties. So this is the main interest of Hetzerk, to uncover these structured principles. The problem is that people have been doing this for more or less the past hundreds of years in some form. So in most research labs across the world, what you see is that people describe something like on the right of this slide, where different spatial scales require different physics, and quite different physics. So while these systems may formally be connected via approximations or some limits, their intuition and their intuition of their interactions kind of get lost in all of the theory and all the different, dramatically different programming code bases. So machine learning kind of gives us hints about how to fix this. So as a very abstract analogy, we have these, for instance, DALL-E 2, which is a text-to-image diffusion model that learns very, very high-order representations of objects. So it's able to parse out sub-objects and learn correlations between these sub-objects of images and text. So obviously there are correlations between these two data structures, images and text, which is why we can imagine characters in a book. But this principle of mapping substructures between two different data structures was really not thought to be possible, especially with current compute power and technologies. So it was so surprising that there is currently a Twitter debate about whether or not models like this are conscious. So in principle, physics is really no different, although it becomes much more important to understand the underlying theories and mathematical descriptions of how subatomic particles and molecules interact. So this is our main focus at Hetzerk, creating an integrated code base to simulate these various physical systems from uncovered and known principles. But how exactly to do this is quite open-ended. So what we envision in the future of development for material technologies is that they will be jointly developed by independent groups like institutions, startups, academics, and even individual researchers to take advantage of large knowledge bases and computational neurosymbolic AI, and especially new incentive structures, which are traditionally not, traditionally we did not have, but which exist on the blockchain. So we are building these technologies and also the infrastructure to try to build the future of computational modeling, especially in its coupling to industrial applications. So our initial organizational principle is we're going to develop a suite of traditional computational methods, which can be used to further develop data sets and interesting baselines to model more advanced machine learning and AI-oriented simulations. And eventually, we'd like to look into integrating this with OpenCog Hyperon, which is SingularityNET's neurosymbolic framework. So we'll be working with SingularityNET and NewNet. And essentially what this collaboration will allow us to do is replicate a lot of the good properties of cloud services on the blockchain. But this also means that we can run theoretically large-scale simulations, similar to what is being run on supercomputers, but without too much overhead, but with a much stronger incentive structure for the community, especially for open source communities. And a second driving principle of this collaboration is that there really is no interest or no useful way to combine different algorithms, especially at different scales. So if you're studying molecules or atoms or proteins, they're going to have a lot of different algorithms that try to simulate the behavior of these things. And there's no really good way to know how to combine these things. So the crucial step will be scalable AI, which really wouldn't be possible without these decentralized platforms and a lot of the ideas running around in the SingularityNET's offices. So yeah, that's kind of, I hope, the overarching view of us. And yeah, maybe we can talk a little bit.
This is thank you for this presentation, Justin. I'm so glad to have you aboard here.
Yeah, me too.
It's amazing journey that you're on, and looking forward to what it will end up to. I have a number of questions actually, but let's start with the first one, which is maybe most top of mind also for the community. Maybe it's not the most interesting one, but what do you expect will land on our platform first in terms of services, and who will be the users of those services?
So the very first algorithms that we will have implemented is traditional algorithms. So molecular dynamics or quantum simulations. So under the quantum theory, we're looking to develop some density functional theory, which are really just calculations to understand the electron correlations of usually small molecules, but there are variations of this algorithm that expands up to millions of atoms. So large-scale simulations will be quite difficult, especially with the current state of NewNet. But hopefully we'll have a lot of prototypes on a diverse set of traditional algorithms, which we can benchmark further developments. So then we want to, first of all, integrate more or purely AI-driven simulations. So things that a neural network might learn from a data set of quantum mechanical properties. But eventually so those are the first two things. So AI developed algorithms and traditional simulations of molecules. But we want to incorporate these two things in a highly parallelizable fashion, which is more open-ended. And so that is something we'll see eventually, hopefully in the next year or two, if things go well.
If you're talking about simulation of molecules, then I'm thinking about these must be an enormous amount of potential amount of API calls to that service that you're thinking about. Is that correct?
Well, it really depends on how you partition the API calls. So if you're looking at sort of a meta algorithm, or like almost like a brain that tries to get different services from different pre-trained algorithms, then yes, you'll get a lot of API calls. But for instance, you can also imagine about a kind of a meta algorithm that prior to simulations kind of symbolically extracts information from a bunch of different pre-trained models. And so before it starts the actual simulation, it kind of gets a meta theory of prior knowledge about what you're simulating. So in this case, you'll still have a decent amount of APIs, but it'll be less APIs than if you're trying to call each algorithm at each time step, for instance. So it really depends on the specific type of implementation that we're doing.
Well, it does. What it brings to mind to me is that there's one missing logo in the logos from SingularityNET, which is Hypercycle. Are you aware of Hypercycle?
So Hypercycle is quite new. I've read their white paper, and I'm highly interested in learning more about it and how it's integratable, especially with NewNet. But yes, I don't know enough about these things. Also, at the current stages, we're not too interested in all these micromanaged payment services, especially because Hypercycle isn't at that stage yet where we can actually use those services. But once Hypercycle, I mean, all of these platforms still have room to progress, especially for what we're trying to do. I mean, we're essentially trying to replicate, high performance computing clusters. And so it's going to be, millions of interactions between, nodes dispersed across the world. And so, there's still a lot of development in front of us. And so, yes, Hypercycle in the future might be a large part of that, but it needs time to unravel.
It's very interesting to see this use case of yours that will actually connect all these parts in our ecosystem, and all of them have a very important role in that. So yeah, I think it's a great use case to be putting on our platform. But what I do wonder about, who would be the customers of these AI services, and how will you look for adoption in the markets?
Right. So, the ones off the top of my head are essentially, or at least our initial focus is going to be on the pharmaceutical industries. A lot of effort by these pharma companies, and also, data-driven partnering companies for these pharmaceutical companies are trying to understand, the potential energy surface of especially protein ligand interactions. And so, what ends up happening is that these pharma companies, they partner with smaller companies, and maybe they have access to AWS or Google Cloud, and they can run some interesting simulations. But they're a small team, and their access to data is usually going to be quite small. But what we have is that we have, especially if you're able to grow an ecosystem, especially in academic and industrial, but we're going to be able to build quite a large data set. And so, at least without the advent of new technologies that don't need quite a lot of data, we're going to be able to generate a large amount of diverse types of data sets, from proteins to quantum simulations to even subatomic simulations, so like quarks and things like this. But we'll find ways to integrate all these types of information, and yeah, eventually we'll have interfaces in which these pharma companies can kind of develop their new drugs or their new protein therapeutics in a more decentralized way, so that they don't have to target specific companies, but they can target this this community of people that are trying to push forward these new principles in physics and machine learning.
Wow, that is just hugely ambitious, right?
Yeah, it's quite ambitious scenario.
Justin, if I may, you're thinking sort of like a deep mind as a service. That's sort of your goal, with privacy preserved data sets that like pharma companies can push to you. Is that one way to think about it? That's
one partial way to look at it, yes. Okay. But for instance, like we hope to build a lot of academic collaborations, and through these academic collaborations, they're very, very, especially in the computer science field, that they're very open to sharing their data, and especially sharing their models.
And sharing their compute power.
Yes, yeah.
Okay.
But I mean, in principle, though, we shouldn't need too much outside compute power, because if we create the correct incentive structure or cycle, as you might say, that being able to develop these new technologies in partnership with the industry, like developing new drugs, should it power a lot of the financial incentives through NewNet and SingularityNET from these industrial partners. So I'm not sure if we need too much external.
You can imagine sort of the NewNet, services running sort of in a decentralized manner, right? Let's say I'm a research institute, I can run NewNet services and sort of join the network in some form of manner. That's very cool.
Right. Yeah. So if we have a large enough ecosystem, especially of academic partners, that ideally we'll have a diverse set of algorithms too, that we can kind of nitpick together in useful ways to simulate the different complexes.
And completely tangential, have you taken any inspiration from sort of Bronstein's geometric deep learning or something?
So the specific algorithms for the AI is not quite, we don't know exactly what we're going to implement, but they would be, it'd be very possible for them to just implement their algorithms together, at least at a future state. So eventually we want to have automated processes that kind of, pick which are the right algorithms to run at the right time, or, extract certain aspects of specific, extracting symbolic knowledge from neural networks, for instance.
Super.
So there's a lot of cool ideas, but it starts at the very beginning, which is implementing.
So, on a personal note, I think both Parag and I, we have aspiring physicists in the household, so they're very interested in the quantum side of the business. So,
yeah, okay, we can talk.
There are already some good dynamics going on here. I'm thinking,
I'll shut up. Yeah, you're right.
I'm thinking of two. Talking about dynamics. No pun intended. I'm thinking of two things. First of all, I think I can imagine that partners that are working with Rejuve might also be partners that would be working with your platform in the future. So there might be some potential. Another thing that I wonder about, but I'm not sure, if you're talking about simulations, are you talking more about mathematical simulations or also about visualizing these things?
So visualizing would be something that'd be useful for the interface between, what we do and industrial collaborations. Like, for instance, when you develop drugs, a lot of the intuition behind how a ligand or a small molecule binds to a protein is done visually. So at least for a large majority of people, visualizing these processes will be highly, highly beneficial, especially to understand what's going on. But that will not be something that we do in the beginning. So that would be something that we'll try to develop later on.
A lot of reinforcement learning, you're imagining.
Yep, that too.
Hey, Justin, I had a quick question for you. Does your model only apply to organics, or can it be used for inorganic molecules?
Yeah, so like I said, there is no specific model. But to answer your question directly, yes, it's quite general in a sense. But to be a little more specific, you can train specific models, for instance, on specific data sets, and maybe some of those data sets are purely inorganics and some are organic, or some may not have any notion of what this means. So maybe you have a data set, for instance, of of genomic information, but even genomics has correlations with ab initio physics. So the scope in which we can try to integrate information is quite large, and so that there's no one model in a sense.
So when you're developing, I should say, so modeling, do you take into account different parameters like heat, temperature, or environment, pressure? How are you developing? Are they specific, or is there just like a general template, or does the user provide the specific parameters?
So that will depend really, really highly on exactly what models one is developing. So the ones that we're starting with, so what you're basically asking is, are we dealing with statistical ensembles, things that you'll find in maybe like a thermodynamics environment?
Right.
So yes, we will be developing some algorithms that have this thermodynamic properties that are pressure, temperature, and things like this, but also other more ab initio models that don't really that are working on such small scales that they don't have these macroscopic properties of systems. But yes, these are still very, very important, especially if you're talking with the pharma industry, because what they mainly care about is the free energy of a system. So to answer your question, sometimes yes, sometimes no.
Are you thinking about carbon dioxide processes?
Oh, I was thinking in the terms at the molecular level of carbonation. showing the electrons and the valence switch, which enables carbonation for CO2 to bind to the mineral feedstock. And these are all affected by pressure, temperature, environment, whether it be an aqueous environment or a dry gas environment. But to show the interaction in the environments that we've modeled our own, but to see at a molecular level how that affects the binding properties of the mineral feedstock and also the CO2 molecule. So, I mean, that's one of the things that we can't see, and nobody can really see that yet. So I hope this comes through so that we can actually perhaps see at one point the moment that CO2 binds with mineral feedstock and how can we translate that into large scale and repeatability or replicability.
Yeah, so it would be a very interesting use case, especially once we have, you know, a working prototype. But yeah, so future collaborations for sure.
Yeah,
Wow. We're just with 3 groups here and there's already this dynamic going on. So that's just great. I love it. But we have one more team waiting here. Subir from Zero to AI. Yeah, of course, about what we're going to tell. But yeah, looking forward to your presentation.
Thank you. You know, that's a tough act to follow. So Justin's, you know, super presentation and Johan's super presentation. But and, I will put all the pressure on my co-founder Parag. Parag's going to show you a little demo, maybe, and then we'll do some Q&A. Parag.
Sure. Hi, everyone. Really thrilled to be part of this community. And so what I'm going to do is start with, you know, a brief demo of the Zero to AI platform with, you know, through an app that we have that runs on a smartphone. And then Subir will add colors and then kind of will talk about, you know, what specifically we plan to accomplish as part of this engagement. So let me start sharing my screens and get right to it.
John, how are we doing in terms of time? We can go over.
For me, I have some additional time. I actually took some extra time also in the meeting. So if the others also, if you have to go, you have to go. Then just go. And for those who like to stick around, please do. Until now, I think it's a very interesting set of presentations. So I'm having big fun here.
Okay. So let me ask the team, can you all see my screen that I'm sharing? Yes. Yeah, okay. All right, so this is a kind of a, you know, Zero to AI app that's running from my, you know, phone. So what we are providing is, making this whole, you know, AI apps, as we call it, accessible. So behind the scenes, we are kind of, you know, regularly collecting the best of the open source AI models available, automatically testing them, ranking them, and surfacing on the platform the best of the best, and packaging them with the interface. So anyone in the world with a smartphone can easily access, interact with it. And, you know, we'll show you, today we have some, you know, basics to demonstrate the capability where you can kind of take that app and make it your own by personalizing it, sharing with friends and family. And then if you think that there is something even a broader community can, benefit from it, and then just right from your phone, publishing this app as an kind of NFT on OpenSea's marketplace. For once it's there, it's available to everybody. You know, if somebody finds it interesting, perhaps they can purchase it. Down the line, perhaps somebody can rent it. And the other aspects of it is that, all the feedbacks that happen on the platform is collected on blockchain, and so it's kind of something very open, immutable, trusted, aspects of it. So let me just, go through. So today we have two categories of, language and vision. So let me just take you through a language. Again, just imagine, 6 months from now, there will be hundreds of apps on this platform. Today, we are just demonstrating with 6, different category of, let's say one of the, AI chatbot is there, an app that can, quickly, check the plagiarism in the text, an app that can, kind of complete your thoughts, a translation app, app that identifies the filling in the sentences, and a, summarization app. So if you want to, take a look one of them, you can just simply go to the next step. Today we are, referring to as a kind of a guided search and making it, super simple for anyone. So this could be, now you can further fine tune that, do I want something, an AI app that's trained on a general, text, where it be clinical, tweet, so forth. So let's click general. You get a choice of, do you want a model, you want us to surface the model that's something runs very quick, but may not be, 100% accurate, let's say. Or you want something very accurate, but may take time. So let's pick a fast. And then what happens is that the platform will, based on the, input, it will, kind of present you with a little animation of a chatbot that it thought was, something what you would like to try. So if you like what, find it interesting, and then you really want to in live, play with it, you just click on a try now. And then now the magic happens behind the scene. It's going to take the AI, model, which is just a blob. It's going to attach dynamically, collect all the assets, attach the interface, and will present you in, in matter of minutes. So let's give it a minute.
So, Jan, 2 things, right? Anand was saying, right? So easy it should be, his grandma can use it, right? That's sort of, I didn't say anything at that point. That's sort of our vision too. We want to really, really make it easy. And that's sort of the zero to AI, right? That's our audience. And all of this is happening sort of behind the scenes. It's all dynamic, right? So it's not like pre-canned anything, right? We are surfacing these automatically, and we are ranking them and presenting them automatically.
Yeah, so here is a sample, like a chatbot. I won't go into too much detail, but you get the kind of an idea, you can kind of, and there will be many, many more chatbots of different types, different data trained available on the platform. So the next thing one can do is that you want to kind of, personalize this to, kind of your likings. Today, we are just, kind of demonstrating the concept. So say I may call it my chatty. I may want to give it a little skin to this app. I go to thing. Let me take, let's say a little background. We save it. Now it's going to kind of, give it a smaller tweaks to the,
Can you hear him? I guess.
No, I think we lost audio.
Okay. But essentially what's happening is it's creating personalized incarnation of the app. It's like a frozen artifact that maps to the changes that a user has made. And it's sort of doing this in real time and creating a version of the app on the fly.
Can you guys hear me now? I can hear you all clearly.
Okay, yeah. No, we can hear you now. Perfect.
Thank you. All right. Sorry. Okay, so again, this this would be further down the line, lot more personalization. You can even further fine tune with your own data set to make it really work the best for your environment. But just to demonstrate, now this is like little my chatty chatbot. I can quickly share on with any on social medias. That user can just simply click on that app and kind of experience it, give me feedback, thumbs up, thumbs down, comments. All of those feedback would be captured on the blockchain that we are currently kind of working on integrating with Ceramic as the backbone for that. And then here is something that I can kind of like I want to publish this as an NFT, so let me call it my.
So sort of the intended audience is, this is sort of your go-to place for whatever is the state of the art in AI, be it the latest RL model, right, the latest GAN, all of these things will be surfaced automatically. So, whether you're looking to learn AI or probably find a solution or commission somebody on the network to build a solution for you, this is, we expect you to come here. That's sort of our vision. And you can obviously, lock your sort of, efforts into this commercial form as an NFT, which can then, we'll not go into the details of, shared NFTs and things like that, but, everybody's contribution, right? If 7 or 10, 15 people were involved in creating this app, all of their contributions will be automatically captured as part of this NFT publishing process.
So I'm just showing here kind of an already populated, things on the, OpenSeas, through our network. One can, simply click on this icon here, and actually it will, bring up on our, platform. Can interact, provide feedbacks, things like that. And let me now take you back to the app and give you, a little bit about some of the vision apps that we have. So on the vision side, again, we kind of limited to kind of 6 different types of category, simple little fun to have for anyone today. Take, pictures of your phone and creating little arts, tracing your pictures, take a picture and then kind of have a visual Q&A with it. We had a, specific use case to be able to kind of, with a night vision app we call, you can identify, from very low light pictures and objects, and kind of another app that takes, kind of a picture from your phone. You want to be able to publish it, but, hide your identity. So again, so let's take just for a, quick tour of, this, what we call inspector. Let me try that. So in the parallel, we are also working on kind of a developer portal. So for all the creators in the world to kind of, have a super easy way to contribute the custom model to the platform. It'll be more of like, just drag and drop, means of doing it. So here it's a simple example of a little app came here. Let me just give it a one quick try. So there's a picture of me and Subir at a bar drinking beer. So let me see what comes up in terms of image captioning. And again, you as a user, you will be able to kind of, oh, here it's already done, be able to provide that, hey, this sucks, this doesn't work for me, and all that feedback will be captured and be kind of, used in ranking what you see surfaced the next time. So here is a couple of men sitting next to each other, drinking beer. Let me try, see what it is any better than that. Not bad, drinking beer. So that's kind of more or less like, capabilities we have today. And I'll kind of turn over to Subir to kind of add colors.
So maybe I'll say a couple of things and then we can take some questions.
Yep.
So what we're expecting to do with the sort of our SingularityNET collaboration over the next few months is to, what we will start with is, so we are now sort of crawling the web, specifically Hugging Face, OpenVINO, and a few other places to find these models. We will also be surfacing existing services on SingularityNET Marketplace. Basically put this sort of skin on top, right? You can consume a SingularityNET service and you can customize and go through this entire cycle, including sort of publishing as NFTs. So that's our first step. And what we think is our final step is this publish process that we have shown for custom models that we can create and publish. They should also end up as SingularityNET services, albeit with a much friendlier interface. So that's really our goal in the next few months.
Wonderful.
Questions? Yeah.
Wonderful. Well, first of all, let me make this clear to anyone watching this video. So what you're actually doing is taking a service. You're basically a meta platform, right? You're taking services of different platforms, and one of the platforms would be SingularityNET AI platform. And whenever somebody is using your app and using the service on your app, actually an API call is being made to our platform where
Correct,
the service lives. So that's already a very strong and interesting use case. But actually, what is really impressive, what I really like, is that you're making a showcase for these services, and at the same time you're collecting feedback from your community about that service. So anybody who's making a service that ends up that is suitable also for your platform, because maybe not all services are equally suitable, but you're creating this showcase for that service and giving feedback to the developer so he can improve on that service. Is that correct?
No, absolutely. So what we say is, for example, right, when you start with an open source model, you start with sort of Google's benchmark or Facebook's benchmark. That's great. But what do the users really think, right? When it's out in the wild, does it really work for their kind of data? So we are trying to capture all of that and sort of, in sort of this immutable fashion, and use that to both rank the model, inform NFT price, and, sort of infuse that into sort of the mechanism, the incentive mechanism.
Yeah. I can imagine, for instance, a sign language service on that app, just to name a random thing. I think it would be very interesting to have it there and to see how users.
Absolutely. I think we, as you guys develop your cool stuff, right? We expect some of them will be sort of infused into our platform. Hopefully, we'll reach a wider audience, and we can all have fun.
Yes.
I mean, it could be like simulation stuff. I mean, quantum simulation is very cool, right? You push a button, you come back in 5 minutes, and it's good. It need not be DALI V2, right? It could be, Justin's V3.
Yeah. So your app is targeted at very different target audiences, not just at plain consumers.
Correct. So, and we are actually starting a little bit of an AI mentoring program with high schoolers around our app itself. So we are targeting sort of the education or getting people up to speed, because both AI is great, but very few people can consume it, and tying it with Web3 and wallets and this and that, right? So you didn't see any of those things, right, in our app. You didn't have to know what a wallet is and all of that. So we sort of hide all that complexity.
Yeah, and how does that work? Because somebody has to pay for those services.
No, good question. So where's the magic? Are we just sweeping it under the rug? So what we do a little bit, we do this sort of the Zero to ER network itself sort of holds custody of these NFTs, and if you meet certain criteria, we do drops. If you actually come back with a wallet, we can push it to your wallet. We just postpone those steps. We don't want you to be sort of mired in those sort of detail immediately. Those mechanisms are all great. They can be sort of, you can leverage them over time. That's sort of our feeling.
Yeah, in a sense, it reminds me of our own Song Splitter app, which is also a showcase of a service that we can do. And we wrapped it in an app to show how it can be used. But that's just one service in one app. And what you're basically doing is to create this front end for a lot of different apps and also different front ends. Actually, it really sounds like an extension of our platform and infrastructure that could be very useful. And I hope that in time your app will be flooded with services from our platform, so that the rest is not that important.
Right. No, and in both directions, right? We are also hoping to make this, creation of services in your platform also, reach a broader audience, if you will. Yeah. And to say, not to say, we have definitely drawn inspiration from your original white papers and things like that. So some of the thinking that has gone into your platform, I think we are, in some ways, we are, reinventing some of those aspects in a slightly maybe maybe a 2022 way in some ways.
Yeah, great to hear that. Great to hear that. We're already thinking about 2024 and 2025 ways, so we'll keep each other.
No, absolutely, absolutely.
One last question about the OpenSea and the NFT connection. How important is that in your whole concept?
So we thought that would be a nice sort of arc to complete the story. It doesn't have to be an NFT. It doesn't have to go to OpenSea. It can go to other marketplaces. But we want to make sure that the fact that you built an app, right, and you did something, somebody helped, somebody provided the app, somebody helped test it, somebody put a skin on it, all those things should be captured in some canonical way. So this is just one way of doing it. And this is not an NFT. This is that, that's going to be sold. It's not like a vanity NFT that you buy, but it's just a question of, capturing value, right? Yeah. And it doesn't have to go to OpenSea. It can go to another marketplace or a custom marketplace. This is sort of our, first incarnation, if you will.
Yeah, it's a nice way of getting outreach for your app and getting more eyeballs and attracting people.
Right, right.
And it would be even more interesting if you have visual apps that make visual transformations of sorts, and then have those.
No, we do have some generative, GAN-based apps that some more are coming. Yes, absolutely.
Nice. I love the addition, guys, and I'm really happy with these. Really, truly happy with these 3 wonderful teams and projects. You're all different. But you all bring something very specific, unique, and potentially very important to the platform. So great work, and looking forward to what you're going to accomplish, and looking forward to seeing your next steps together with all the community members looking over my shoulder, metaphorically speaking. So let's wrap it up. Thank you for this presentation. We all hope to see more of you in one way or another, and we definitely hope to see more of your products coming out on the platform, and we're all looking forward to it. And I hope it will also not just give us successful services from your own teams, but it will also create this vibe on the platform that will inspire other people and other teams also to put their services. If I see the dynamics in this small group already, I can only imagine what will happen if other people out there and other developers and other AI developers out there will also be joining the party. So glad to get this party started right now, and looking forward to what the future is going to bring. Thanks a lot.
Thank you.
Thank you all. Thank you.
Thank you.
Bye-bye.